Welcome to Revolution Against Evolution. I'm Doug Sharp. This is Rich Geer.
Good afternoon.
Today we are at the Bandelier National Monument and we are interviewing Dr. John Baumgardner, and he works at the Los Alamos National Laboratories, and he has a model that he's been developing concerning Noah's flood and how this could have worked. Rich, have you read anything of John's and been able to?
I have, but it's been only recently this sort of beginning to make some sense to me, and so I'm really happy to have you here, John, to really share with us and the audience here what really it is you're proposing, the actual mechanics and the theory that would explain how a flood of the magnitude that's described in the book of Genesis could have happened, and what would be some of the effects during and after the flood. What exactly do you call your theory?
Well, I didn't come up with the name, but other people have given it the name Catastrophic Plate Tectonics.
Okay.
Because it's similar to standard plate tectonics, only it's driven by an instability in the inside of the Earth that allows it to unfold in just a few days to a few weeks' time, and cause in effect a resurfacing of the planet in a very brief period of time.
Well, I've heard it described. I think Russ actually used these words as opposed to continental drift. We have continental sprint. Is this
right?
Okay, so we're talking about the crust, or how much of this. Basically, before I put my foot in my mouth, I'm going to let you do most of the talking here, because what happens is the areas we call continents exist on top of what are called plates, correct?
Right. Maybe we just to help the audience out, let's have just a brief lesson in the structure of the Earth.
That would be good.
Okay. And the innermost part of the Earth, we know from seismic studies, is very dense and has the density of iron, and moreover, it's been determined that it is liquid. So we have about the inner half of the radius of the Earth is the core, most of which is liquid iron. It's so hot, it's in the liquid state, and the innermost part of the core, however, is solid. So there's a solid inner core, also made mostly of iron, and the liquid outer core.
Okay.
And that comes out to about half of the radius of the Earth. The outer half of the Earth's radius is made of silicate rock in the solid state almost everywhere.
Okay. And
this region of the Earth is called the mantle of the Earth.
And that's solid.
It's solid. It's very hot. It's on the order of 70–80% of the melting temperature in most places. So it's not far from the melting temperature.
Okay.
So it can deform. It can deform plastically, but it's nevertheless solid, not liquid.
Okay.
That's a common misconception. Many people think of the mantle as being liquid, but it's liquid rock, but it's actually solid.
Well, where does the molten lava come from?
Exactly what I was going to ask.
Right. Well, there are certain circumstances where melting can occur, but these are relatively special circumstances. Especially if you live in the Pacific Northwest, you're aware that we have active volcanoes in that part of the United States.
The rim of fire, isn't that whole?
And more generally around the Pacific, there's what is called the rim of fire around the margin of the Pacific.
Okay.
Volcanoes in South America, Central America, a few in the Pacific Northwest, active volcanoes in the Aleutian Islands in Alaska, and then along the western Pacific, many places in the western Pacific.
Okay.
These volcanoes, it's been realized, are associated with oceanic plate sinking into the Earth's interior, and when that ocean plate plunges down into the Earth, it carries with it some sediments on the top of the plate.
Okay.
And those sediments generally have lots of water in them. And so when that material gets deep enough and hot enough, it turns out that water makes it easier for this rock to melt. And these sediments also are easy to melt. And so when that material gets down to about 125 kilometers, roughly 80 to 90 miles down below the surface of the Earth, it melts and comes generally fairly quickly up to the surface and produces volcanoes. So that's the reason we have volcanoes around the Pacific, and it's associated with these plunging plates that are going back into the mantle, back into the Earth's interior.
So we have evidence, I think this ties into your theory about the flood, right? So we have evidence that today this is happening still. This is still going on.
Right, but it's going on very slowly,
Okay.
very gradually, and the scenario that I believe occurred and is responsible for the flood happened millions of times faster than what we see occurring today.
Wow.
One of the things I wanted to ask you, John, had to do with how this subduction could have gotten started and how it could have gotten, how it could have been happening rapidly rather than the uniformitarian model that is currently promoted.
Right. Well, if we look at the rate that plates are moving today, there are several places where it's easy to measure, like along the San Andreas Fault in central California. It's very heavily instrumented, and they can measure motion of about 2 inches per year across the fault as the Pacific plate slides against the American plate.
Okay.
So that's about the rate that your fingernail grows. So it's a very, very, very slow process. Okay, and we also can use GPS these days, the
Global positioning
global
system.
positioning system, to measure these things. You know, there is this kind of evidence that the plates indeed are moving. So the question is, if we want to have motions large enough to open up the entire Atlantic Ocean, the entire Indian Ocean, and replace all the pre-flood ocean floor in just a few weeks' time, what conceivable mechanism could cause such a thing to happen?
Exactly.
That's the central question, I believe, for any kind of flood model. Any viable flood model has to have an answer to that question. And I'll just say I've spent the last more than 20 years of my life working on these issues. But it became pretty clear in the early 1980s to me that what the answer was. And it turns out that this hot rock that I mentioned that makes up the mantle, it's silicate rock made of silicon, oxygen, magnesium, and iron mostly. It's a crystalline rock made up of those elements. It turns out that this material weakens as the temperature increases. It also weakens dramatically as the level of stress increases. And it turns out that this sensitivity to stress is even more important than the sensitivity to temperature.
Really? Okay.
So do you propose a meteorite impact or something like that to start this whole thing?
I am cautious about. I don't claim to know what triggered it, but a meteorite impact could have triggered it. Yes.
So like popping a balloon or something.
But once what another issue here is, what is the energy? Where does the energy come from to drive it? Well, it turns out that it's just the weight of the plate itself, the gravitational potential energy of this heavy plate at the surface. It's heavy because it's cold relative to what's below. It has this higher density than what's below it, so it has the ability to sink.
Okay.
And when it starts sinking, that gravitational potential energy gets converted into kinetic energy and then into heat as it sinks.
Once the whatever it was starts the instability, it's going to take off into its natural course.
If the conditions are right, it'll take off. And what happens is, as this thing starts to sink, first of all, there is some heating around it because it's deforming the rock around it, and that deformation produces heating. The higher temperature causes it to be a little weaker, the material in an envelope surrounding this sinking plate, and as it sinks faster, the stresses increase, which weakens the material even more, allows it to sink faster, which weakens it more, allows it to sink even faster, and you get a runaway situation. So the velocities can go up by I believe, in order to have it happen during the time scale given in Genesis, it has to weaken by on the order of 100 million times. The velocities have to be about 100 million times higher than we observe today. But I have done computer calculations which show that naturally occurs, that when we put in the physics of this weakening, you get increases in velocity on that scale.
Okay, so then let me ask you this, two questions. First one is, then what would stop, okay, it's going down, is there a point where it just would naturally stop? Or, I mean, once it begins, how does it end? And then also, what about all the actual, I guess the water on top of we're being covered with water. The description of the Genesis flood, if you will, is a world inundated with water. And what happens, how does that water stay on the top, or what happens to that water, I guess?
All right, first the question, what causes it to stop? Basically, the thing that causes it to stop is when this pre-flood ocean floor is all subducted, and there's no more of that heavy pre-flood ocean floor to subduct anymore, and it all reaches the bottom. Just like you pick up a rock here, if I can find one.
Okay.
You pick up a stone,
right?
And its gravitational potential energy, when I release it, gets converted into kinetic energy, and it stops when it hits the bottom, and when it hits the ground. That's what we're having, the heavy plate sinking down through the mantle, but when it all gets down to the bottom,
When you say the bottom, you mean the bottom of the mantle?
The bottom of the mantle.
So it stops at the core, is what you're saying.
That's right, on the top of the core.
The core would stop the subduction.
That's right.
All right. So then the water will stay floating on the top during this time, or?
Well, you can. I suspect. I mean, it's going to cause all kinds of havoc to be unleashed at the Earth's surface, and let's just focus on a few things. One of them you mentioned, the water. Okay. What about water? Well, if one side of the plate is sinking into the earth, on the other side you have plates pulling apart, and you have hot material from the mantle rising up to fill the gap. Okay. And in general, this stuff, even though it was below the melting temperature when it was deeper down, when the pressure when it rises and it sees less pressure, the melting temperature decreases, and suddenly this rock finds itself above the melting temperature and melts.
Okay.
And we have magma. So we have molten rock at about somewhere on the order of 1,500 degrees centigrade in direct contact with ocean water. So we're producing this stuff flashes, this water adjacent next to the rock flashes to steam, and we produce incredible steam jets at the bottom of the ocean. And just recently, in the last few months, I've been working with a graduate student, a Christian graduate student who's come to Los Alamos to work on a project, and this physics is his specialty. And working with him, we've come to realize that these jets reach supersonic velocity, and in fact, way beyond hypersonic velocity, and we get steam that is accelerated to, at least some of it, that is accelerated to the Earth's escape velocity. So we have like a huge rocket engine, I mean gigantic jet roaring up out of the ocean, completely going through the atmosphere, and having enough velocity to escape to space. Some of the water is going to escape to space.
Are you talking about the whole area where the magma's coming, or separating? That's, or would it be many jets coming up, one big jet, or?
Well, in general, these plates are pulling apart in a more or less there's sort of a linear seam, a linear fracture that's opening up.
You're talking about the Mid-Atlantic Ridge.
So it's something like the Mid-Atlantic Ridge. You're going to have jets coming up all along the mid-ocean ridges.
Okay.
And there may be some localized single jets, but in general it's going to be a sheet, a sheet that's like a jet.
Okay.
And so this, I've calculated that there's enough steam being produced. There's going to be some of the ocean water that gets entrained. There's going to be a lot of the rock, the molten rock that gets pulverized. The velocities down the bottom are high enough for cavitation to occur to just pulverize this rock, at least some of it.
Turn it into sediment?
Turn it into fine sediment, and that will get entrained in the steam jet. So not only are you going to have intense global rain, but there's going to be a lot of mud coming down out of the sky as well.
Okay.
So we're still working on how much rainfall would be associated with this process, but it appears that many feet per hour of rainfall, as long as this is going on, would likely be occurring over all the earth.
40 days and 40 nights worth?
And so the Bible says 40 days and 40 nights, so we have a clear, we know how long it went on. But the point I'm emphasizing is how intense the rain was. That this mechanism is potent enough to produce 3 feet, 5 feet, 10 feet of rain per hour, as long as this is going on over all the earth. In rainfall like nobody's ever seen before.
I would have to think then that God would have had to supernaturally protect the ark during this time, because obviously this would have been a cataclysm that would have really caused some large waves.
Right. Well, there's a cryptic phrase in Genesis 8:1. It says, "And God remembered Noah." I agree completely that this kind of catastrophism required some intervention on God's part to keep the ark from being destroyed. One thing for sure, I'm almost certain the ark had to be in deeper water to keep it from being torn apart.
That's what I've wondered, yeah. I mean, people have made models of the ark, and it's a very stable barge-like structure based on supposed eyewitness descriptions and things. But even so, based on what you're saying, you don't want to be by that steam jet. You've got no hope of getting through that. I don't care what you've got it made out of, or what it's made out of.
Well, my point was that people have to have a naturalistic explanation for everything, and in this case, I think a supernaturalistic explanation is better, because God did remember Noah, and
as far as the preservation of them, yeah.
And so there's always these people who dispute, well, the ark couldn't have been able to structurally handle this whole disaster, and certainly it could have if God had actually remembered Noah.
But you're saying if they were in an area where the water was deeper, or away from the spewing jets, if you will, if they were far enough away from that, the floodwaters would have come in. And again, granted, I'm not trying to appeal totally to naturalistic explanations, but the fact is that water does act like water, and that he did have him build an ark. He didn't just put him in some water bubble or something. There was a physical structure he had him build, so there must have been certain precautions or areas perhaps that he was at that it would not have.
Right. Well, the wave amplitude would be smaller where the water was deeper. So there's two things: it had to be not in shallow water, and also not near one of these jets.
Right.
So that, I believe those are two big criteria that seem to be required for the ark to be relatively safe.
Do you believe that the surface of the Earth was a little bit flatter than it is today, and that mountains rose up and you had
trenches went down.
Trenches went down. This is the classical argument: where did the water come from? Where the water
Right.
go?
That's an excellent question we need to talk about here. One thing in this catastrophic plate tectonics picture is that this new ocean floor that gets produced by the hot magma rising up and forming new ocean lithosphere, it's called, the plate, new ocean plate. That rock is going to end up warmer, much warmer than the rock that it is replacing. And what that means is that the depth of the ocean is going to be smaller because you've got less dense rock making up the floor of the ocean. And typically along the mid-Atlantic ridge, the topography is about 2,000 meters, about 6,000 feet higher than the deeper ocean basins. That's because you've got warmer rock beneath the mid-ocean ridges. If you make all the ocean like that, you're going to raise the bottom of the ocean by on the order of 6,000 feet or so.
Wow.
And so that's going to raise the world's sea level by 4,000 to 5,000 feet. So that's one source of a increase in sea level. So in addition, all the dynamics of the flow in the mantle that's being produced by these sinking plates. Generally, these plates are going to be sinking, plunging into the earth next to a continent, and that's going to tend, just like you drop a rock in a bucket of tar or a bucket of honey, as that rock sinks, it pulls the surface down. Similar way, this plate sinking next to the edge of a continent is going to pull the continent's surface down. So there's going to be a lot of dynamic up and down motion of the continental surfaces during this catastrophe. So there are a number of ways that the continental surfaces get flooded. Now, as far as the height of the mountains before the catastrophe, in general, I believe they are not. These mountains were not as high, nearly as high as the mountains we have today. And one of the after effects of this catastrophe is, well, during the catastrophe, this light continental crust gets moved around, especially where next to subduction, it's going to be thickened. And when these forces go away, these rapidly sinking plates, when those forces disappear, this light material that's been thickened is going to bob up like a cork to produce all the high mountain ranges we see today, the Andes, the Rockies, the Alps, the Himalayas.
And so when you get the people who criticize the flood model because it would have had to have been higher than Mount Everest, then they don't realize that mountain building took place during the flood.
Yeah, it would mostly be after the flood that these high mountains were formed, and Mount Everest is included. It would not have existed before the end of the flood.
So much catastrophism continued for quite a while after the flood itself. The initial flood stage was over. You still had catastrophism going on for how long would you say it was going on?
Many centuries. I'd say 500 to 1,000 years is going to be major catastrophe. This Bandelier National Monument, where we are, is a we're on the edge of a large volcano. The caldera, the depression in the middle, is 15 miles in diameter.
Wow.
And this thing erupted in 2 eruptions, enough volcanic ash to cover the state of New Mexico, some estimate to a depth of 6 feet, that much volume of material. And primarily, the wind direction was primarily to the east, and so you can find volcanic ash from this volcano out in Kansas and Oklahoma. And I believe a lot of the rich soil in West Texas, where I grew up, is a result of this volcanic eruption.
When do you think this might have happened?
And this was after the flood, during the Ice Age, somewhere on the order of 4,000 years ago.
Wow.
Would you say that there's a lot of the geomorphology of the Earth that has to be explained in post-flood terms?
I would say yes. I believe the ice. One thing that happens in this kind of catastrophe is the oceans get warm considerably, and even the secular geologists marvel that the bottom water in the polar regions, shortly after when you don't find any more dinosaur fossils in the record, was at the temperature of surface water at the equator today.
Wow.
So they acknowledge that there was major differences in the temperature of the ocean. Well, I would assert, and calculations by Larry Vardaman at the Institute for Creation Research confirm that when you have an ocean that warm, it produces much stronger atmospheric circulation. You get much more moist air carried to polar regions, and a much higher rainfall and snowfall in the polar regions. And his calculations show that you can produce thick ice sheets in tens to hundreds of years. And so I believe all of the glacial features, for example, that you see in Michigan,
right,
are post-flood phenomenon. There's a lot of geomorphic processes, geomorphic features that are a result of things that happened after the flood.
Well, you can sort of see that in the geology. There's sort of like the layers in a basin type of formation in Michigan, where on the outer edges you can get more of the older rocks, and where you have it goes towards the center, you get the older to the younger rocks in the middle. But then there's a big cutoff where it just slices all the way across the top, and you've got the Pleistocene type of formations, the later core formations, and that would fit in with what you're saying, is that we had the initial deposition of the flood that produced the lower layers, and then post-flood events producing ice age type of materials. Is that what you're saying?
And then there was the retreat of the flood waters that in many cases beveled off a lot of these earlier layers.
That's what I was going to get to. We asked earlier, before the camera was on there, what major distinction would someone be looking for if they were just maybe starting to look for this? How should you tell something was a post-flood or a pre-flood deposition or activity, if you will? And you gave a pretty simple and straightforward answer that made sense to me, and I think the audience might be interested. Like, how would you know something was before the flood, and what would make it a post-flood activity?
Okay, as far as before the flood, in general, a good
or during the flood too, as well.
Good criterion is no fossils.
Okay.
Okay. So, and we find this worldwide discontinuity in the sedimentary record, a physical discontinuity below which we don't find any multicellular fossils, but immediately above the discontinuity we see an incredible diversity of multicellular types of life.
What they call the Cambrian explosion?
Right, the Cambrian explosion we're talking about. This sudden appearance of diverse plant and animal life. Okay, so I believe that represents the onset of the flood, the beginning of the flood.
Okay.
So through much of the record we find a sedimentary pattern that's especially evident out here in the southwestern United States. Mm-hmm. Layers that are continuous, have identical color and grain structure and so on for hundreds to thousands of miles. You can just track them. Just go down Interstate 40 across New Mexico.
Coconino sandstone, one of those layers.
And one of them is the Coconino sandstone. It's exposed nicely in the Grand Canyon. It's a light-colored layer, not too far down from the rim of the Grand Canyon. It continues all the way across Arizona, all the way across New Mexico. It's known as the Glorieta Formation in this area. And you can stop on I-40 east of Albuquerque and see exposures of it that's essentially identical to what you see exposed in the Grand Canyon.
So how do evolutionists explain this? So do they say that there's some sort of lake that retreated and you had sand dunes form next to it? And
I would say they don't have any answer. If you look, it's strongly cross-bedded. Cross-bedded is indicative of high velocity water transport in this case. And you can look at the orientation of the crossbeds and see that the source of the stuff, the current direction was from north to south, and it was, so you have to look north to find the source of it, and some pretty strong erosion going on the continents, that especially that's right slightly above or near sea level. So you're going to have erosion producing sediments on the continents as well. There's parts of Canada, much of Canada, the Canadian Shield, there's been several miles of rock that's been eroded away, and I believe that occurred during the flood.
Wow.
So there are areas of the continents that are suffering intense erosion.
So the
during this catastrophe.
So the large uniform and I hate to use the word uniform, sort of like strata that you could find for hundreds of thousands of miles, would have been deposited during the flood. And as Doug mentioned earlier, the actual mountain building and canyon cutting would have been, most of that would have been post-flood action.
So we have during the transgression stage of the flood, we have these broad layers of sediment being formed. So those, what are generally known as the Paleozoic and Mesozoic strata, have this character. Certainly out here in the southwestern U.S., there's no internal erosional channels in these things, again indicating a single event depositing all of it.
And it would be mostly marine fossils buried in those?
And well, certainly in the lower layers you find almost exclusively marine fossils, but as you go up in the higher levels, you start getting
more complicated, multicellular.
Well, you get more land types of plants and animals. And here in the southwest, still in the Mesozoic sediments, we have major coal deposits of continental plants, trees, like large redwood type trees, and dinosaurs. But they're still in these widely distributed sediment layers. But they are terrestrial types of plants and animals that you're getting. And then as you go up still higher in the record, you start to see localized erosion and more localized deposition. So you're moving from this part of the flood where there was transgression and rising sea level to a stage where the sea level starts to fall and you have stripping away of a lot of this previously deposited sediments. And then as you go still a little higher, you're finding even more stripping away and a very heavy deposition on the continental shelves. Very thick sequences, like in the Gulf Coast areas. Very thick sequences of sediment.
So when you talk about like the Grand Canyon, for instance, we were talking about Steve Austin and others, and come on to what they call a breach dam. Some of these would have been like post-flood huge lakes or something that would have been maybe left over from the flood. And so, because Grand Canyon has these sediments already laid down, so that would have been done during the flood.
Right.
But the cutting of the canyon would have been done probably after the flood.
Probably after the flood.
Okay.
Now there was a plate, an ocean plate that subducted back into the mantle along the west coast of North America. And actually this sinking plate caused, the motions in the mantle caused North America to drift westward, open up the Atlantic Ocean, and this plate ended up sinking under what is now eastern Colorado.
Oh, man.
And that far east inside North America. And it dragged a lot of this light continental crustal rock to the east as this plate went down. And so so as this was going on, it pulled the surface down. So we had what was called the Great American Seaway running north and south from New Mexico all the way up into Canada, and in this depressed basin is where all these dinosaurs are buried. Okay, now as this plate broke away and sank, the forces decreased, and eventually this material started to rise up again. This light continental crust started to try to reach equilibrium again. But where it was thickened, it really thickened. It punched up new mountains, the Rocky Mountains, and where it wasn't quite so thick, it just rose up to equilibrium and produced the Great Plains. But
that makes some sense. Okay.
And this area right here rose by something like 6,000 feet from slightly below sea level to what is today, well, right here because of the volcano, we're like 7,000 feet.
Right.
But in general, the general area is about 5,000 to 6,000 feet above sea level.
But you got places like in the rock, like in like in Rocky Mountain National Park, they have 14,000 area, but those are unusual. But it's the whole area. Can I ask you a question here? So that just playing the dumb guy here, there's a difference between the crust and the plate, correct? Is that
Right.
That's what but the plate is like right under the crust, and how many plates are there? Would you guess, or
Well,
speculate?
there are about 10 major plates,
Okay.
large plates. The Pacific Plate is the biggest plate, and it's probably about 25% of the whole surface of the Earth is on the Pacific Plate.
So the plates are on the seafloor and under the continents.
All right, so we have these plates are on the order of 50 miles thick, a slab of rock about 50 miles thick, cold enough to behave more or less as a rigid block.
Okay.
And the stuff below it is much warmer and deforms plastically, whereas this stuff, this upper layer, cold upper layer, behaves brittlely. Is a pretty stiff and more or less moves as a single rigid body, rigid block. And where there is a layer of about 20 miles of this continent, what's called continental crust, you have a continent. Where there isn't this layer of continental crust, you have ocean.
Ah, okay. So the plate, if the plate is going down, it actually takes the crust down with it a little bit. No, the crust stays on top.
The crust is buoyant and it's floating like an iceberg, if you will, and this continental crust is essentially non-subductible because of its buoyancy.
Okay.
So it's only the plates without continental crust that can subduct.
I see.
That's why I was talking about ocean plate always
plates.
subduct.
Ah, so you would think the Pacific area or the Atlantic area. Let me ask you this question before I go into that. Do you think the world was kind of in one continent at one time, and then the ocean areas where the plates sunk down were in other areas? And
well, Genesis, in the first chapter of Genesis, on the third day, God says, let the waters which are below the firmament be gathered together into one place, and let the dry land appear. And so and that's just a very brief statement,
right.
But I think it's suggesting a single ocean, and that would almost imply a single large continent as well.
And those would have broken apart during the time of the flood, you think?
And I believe those broke apart to produce, that single continent broke apart to produce the multiple smaller continents that we have today.
Something that was occurring to me while we were talking here is the planetary moon Io may be a real live model of what may have occurred back when the flood occurred, possibly.
Well, I think Io is one of the moons of Jupiter, and there's Jupiter's a big planet, and Io orbits not very far away, and so Io experiences some extreme tidal forces, and so there's a lot of deformation of Io, and that's a source of heating, and it produces these sulfur volcanoes at the surface. So it makes Io a very dynamic planet. But well after I proposed these ideas back in the mid-'80s,
Yes.
An exciting development was the NASA mission to Venus called Magellan. And you may recall that Venus has a very thick, dense cloud layer, so that you can't, with optical method, you can't see the surface of Venus. This Magellan spacecraft had what is called synthetic aperture radar, and was able to image the surface. This radar is able to penetrate that cloud layer, and for the first time we had very detailed images of the surface of Venus. And what that data showed was that Venus had been catastrophically resurfaced in the not so distant past by a process internal to the planet. So
why haven't we heard about this?
I have not heard about this at all.
So most of the surface of Venus is monotonous and flat. It's been flooded with basaltic lava. Other places, there's a higher highland region near the North Pole of Venus where stuff has all been crunched together, and they've got 45-degree slopes on high mountains. It's just hard for scientists to imagine what could support such extreme topography. Again, indicating that the surface is very new, very young. And anyway, it appears that the type of event that I've been describing for the Earth has happened on Venus also.
Wow.
And scientists admit that. And so if it can happen on Earth's sister planet, I believe it's not far-fetched that this same mechanism could have operated on the Earth, and I believe there's overwhelming evidence that it did.
Well, I've been kind of astounded recently with all the big brouhaha excitement about supposedly a flood on Mars, where there's no water on there at all. There's no water at all on Mars.
Yeah, and we asked the same question: where did the water come from?
Where did it go? And I'm saying, well, I don't have a problem with it on Mars, but why is it such a difficulty to believe that we had it here, where we still have 3/4 of the surface covered with water? Can I ask you one more question? We get back a little bit when we talking about the ice coming down during the Ice Age. Why is it, do you think, that the ice settled up in the polar regions as opposed to, were there ice caps before the flood, do you believe, or is that something, a post-flood Ice Age phenomenon that happened during that time? And why did they settle there? Why not at the equator or like off to the side, or why both north and south pretty equidistant from each other? Why that?
Well, I believe that the model I described earlier about strong atmospheric circulation, lots of moist air from the equator, from water evaporated near the equator, was pumped to high latitudes and fell as snow during the winter season, and probably some rain during the summer. But that there was so much snow in the winter that you had a net growth of these large ice sheets, and mainly because of just the colder climate at the poles. That's why we had the accumulation at the poles. We also, in the high elevations, just right around here, more mid-latitudes, there was lots of ice in glaciers. So it was just a matter of where the higher elevation and the higher latitude parts of the Earth that got the ice.
So you believe that? Do you think the poles were colder before the flood?
Well, we haven't brought up the canopy. I think the canopy that's a 100-year-old creationist idea that is now defunct.
That's
but I believe the climate was different before the flood, and that there was some kind of a greenhouse effect. It could have been either due to elevated concentration of carbon dioxide in the atmosphere, and I think there's some evidence for that, and or a deck of clouds high at the top of the atmosphere.
Okay.
Which Russ Humphreys was showing us the big pterosaur in the museum a couple of days ago, and he said that the atmosphere today wouldn't have been able to support that.
This is what I've been asking him for a while.
So one of the consequences of these jets would be that it would almost certainly blow away some of the atmosphere. So that I haven't ever written that or published about, but that's another aspect of these jets, is that the Earth would lose some of its atmosphere.
Are these jets what you consider, or maybe considered, the fountains of the deep? Or?
Yes, I didn't really answer that. Yes, I believe these jets correspond to the fountains of the great deep, and they're like fountains that nobody's ever imagined.
Oh my goodness.
You would say that they'd be different than the springs of the sea that are mentioned in Joel, right?
Yes, I will. Steve Austin thinks the springs of the sea correspond to the, it's sort of the after effects of these jets. The hot rock down there there's what's called hydrothermal circulation of seawater down into the rocks of the ocean floor, the hot rocks, and you get these these black smokers and these
Oh, yeah.
these little
Well, really,
springs coming up on the ocean floor.
What really frosts me is when you have those evolutionists going down there and saying that life is evolving down here because they find all these different creatures that exist at those jets. Well, anyone who knows anything about biochemistry knows that the evolution of life from non-life is really a very difficult.
Fraud,
Yeah, that's a
actually.
fraud.
Yeah.
It doesn't work, and that's what really brought me to the whole creation scenario. Was I was trying to do that in the test tube, and it didn't work very well.
Why do you think, we talked about this before, but many people ask me the question, why is it so important to study this geology? Does it matter? I don't believe in evolution anyway, but they have a hard time dismissing the long ages that we've been propagandized for 150, 200, actually 200 years or so. And it's like, so they asked us the question, why is it so important to come up with these things, to talk about a worldwide flood, or even if a worldwide flood happened, so what? It's like, as far as creation and evolution, what does it matter if the world is millions of years old or whatever?
Okay, I'll try to give you a straight answer on that. It's a direct assault on the authority of the Bible, a direct assault on the authority of God's Word. Because a lot of Christians believe that, essentially believe that in millions of years they can't believe in the accuracy of Genesis, and so their main weapon, their main spiritual weapon, has been neutralized. They're walking around as worthless as far as the spiritual battle is concerned because they don't believe their weapon is reliable.
This is what I feel one of the weaknesses of intelligent design theory is they don't really deal with age of the earth issues. On the other hand, they say that's the creationist weakness because nobody believes in that. I go, yeah, but that doesn't make it wrong. And I think, as you said, one of our most potent, I think, weapons to defend the veracity of Scripture and the historical account is the fact that we have legitimate reasons to believe the earth is very young, according to the chronologies we can find in the Scripture. And so I'm on your side on that. But I mean, I enjoy the intelligent design as far as they go, but I feel that they undermine their own cause.
Right. Well,
by not being young.
just this last weekend, I spoke at a Answers in Genesis conference. I gave 3 lectures, 2 on the flood, but the first one was on the issue of language and design in nature.
Okay.
It essentially was an intelligent design talk. So I have no problem with the work that people in intelligent design are doing. It's just that there's more to the story than that.
Yes, I just am ecstatic to see real geological work because that's another issue that keeps coming up. I keep reading on the internets and things. Well, creation scientists don't do original research, and what you're telling, the stuff that between talking to you and Dr. Humphreys and Doug's talked to Dr. Larry Vardaman and several others, it's very original and exciting research.
Back when I got involved, we had Clifford Burdick, and that was about it.
Yeah,
We're glad to have more people who are real geologists and paleontologists get on board and work with us. And
Well, maybe this would be a good time for a commercial for young people, high school students who are gifted in math and science to consider investing their life in this enterprise, in this battle, getting engaged in this, because there's no limit to good research problems from a creation point of view.
I believe that. Are you involved in the rate?
I am.
Are you? I got very excited about some of the things that were talked about. Is there one or two particular things about that really kind of get your motor running? Is there really that've gotten you, so to speak, found a smoking gun, or something that really goes strongly to some things you've already suspected as far as the radioisotope dating methods in that regard? You might want to tell us what rate means as well.
Okay, rate stands for radioisotopes and the age of the Earth. And there's a group of 7 PhDs, scientists, that came together about 4 years ago, and we just published our first book. It has that same title, Radioisotopes in the Age of the Earth, a Young Earth Creationist Research Initiative, I think it's called, and as a subtitle. And we basically lay out what we believe are the important research questions. And we've already got several of these research projects underway, and the goal is to come up with solid answers to why on one hand we see evidence for so much radioactive decay when, according to the Bible, the Earth is very young.
Right.
We're trying to come up with good answers that will stand the fury and critique of the secular community.
I would need to ask you, Russ Humphreys was mentioning some samples that were obtained from the Jemez Mountains here. Tell us a little bit more about what they found and what it means.
Okay, well, as I mentioned, the Jemez Mountains we're on the edge of a large volcano that erupted during Ice Age times. And during the 1970s, our laboratory had funding to investigate the potential of using the hot rock to generate electricity, to pump water down into this hot rock, produce steam, take the steam, put it through a turbine to produce electricity. And several governments around the world were also interested in this because there are many places in the world where there is hot rock not very far below the surface. Okay, so as part of that project, we drilled several deep holes into this hot rock associated with the volcano. Now, we did lots of analyses and studies, and there was a creationist who worked at Oak Ridge, Robert Gentry at that time, got some samples and looked at how much helium was in small minerals called zircons. And he found that the deeper one went, the less helium existed in these zircons, but at a depth of about 3,000 feet, which was, I think these holes went down to 12,000 feet, but near the top, he found that as much as 60% of all the helium produced by radioactive decay was still present in these zircons. These zircons have high concentrations of uranium and thorium, which, when they decay, produces helium. As this stuff goes from uranium to lead, it in the process produces, in the case of uranium, 8 atoms of helium. So it was astounding to find that 60% of the helium could still be present, because helium is one of the smallest atoms and is inert and is easily diffuses through these rock crystals.
So have you measured?
If they were really 1.5 billion years old, these rocks, you wouldn't expect much helium around.
Right, and the other thing was the helium in the atmosphere that you would expect to find. Is it there?
It's not there.
Okay.
It's still in the rocks. So the issue is why, if the Earth is really that old, why isn't this helium escaped from the rocks, gotten out into the atmosphere? Why is it still locked up in the rocks? And one answer would be that there hasn't been enough time.
It's not that old.
It's not that old. So one of our high priority rate projects is to actually measure the rate of diffusion of helium in these various minerals, and try to show that this just by measured diffusion rates and measured rates of helium, that it means that the helium hasn't been there very long.
So you're working on that right now, as we speak, or has that already been done?
We're still working on that project. We already have some early data, exciting
data. Well,
yeah.
Can you tell us?
Well, yeah, I can say that
we're running out of tape.
The diffusion rates are consistent with an Earth only a few thousand years old.
Oh boy, that's exciting. So that would be a smoking gun, wouldn't it?
Yeah.
Yeah.
Another one that I contributed. It's a long-standing problem in solid Earth geophysics. Back in the late '60s, it was found that the as they measured the heat flow out of the Earth, they found a close correlation between the amount of heat coming out of surface rocks and the radioactivity of right at the surface in these rocks.
Oh, okay.
And that really was a perplexing finding, because they believed that what is coming out of the surface should reflect the heat flow down to deep into the Earth, and
that plays into what you were talking about earlier, it seems to me.
right.
Okay.
And so what I show is that a pulse of nuclear decay, just say 4,000 to 5,000 years ago, will satisfy all of this observational data, and we actually from the measurements we can get an estimate of how much decay occurred. And anyway, this is another example of the type of work that the rate scientists are doing.
Well, that's very exciting. I think that's the question I was going to ask Russ, and I forgot to ask him. He mentioned there seems to be empirical evidence for increases of radioactivity, during the time of the flood and even in Creation Week. And I was going to ask him that, and I kept forgetting to ask him. Is this one of those?
Yeah, this is one of those evidences. By the way, I believe that most of the radioactive decay that we observe in rocks took place during the first day of creation, or perhaps first and second day of creation, and I believe 99% of this decay took place at the very beginning, and much of what we see today is just the result of the mixing of that very strong initial signal as a result of subsequent geologic processes, volcanism, melting, leaching of the rocks and so on.
We hope that you enjoyed our time with John Baumgardner on the revolution against evolution, and we hope that you will tune in next time and contribute to this rate project while you're at it.
One thing, we got a couple minutes. I did want to plug your videotape. John has a tape that talks about the subduction, correct? The theories and more in detail. You want to talk just a second about that?
I gave 2 lectures in January at a camp in Australia for Answers in Genesis, and they videotaped those lectures. Both of them are on catastrophic plate tectonics. Those are available through Answers in Genesis, simple to order on their website, answersingenesis.org.
What's the name of the tape?
I don't know the exact titles, but you can contact Answers in Genesis.
They will know. Okay. Thank you very much.